Thank you. Yeah, also a warm welcome from my side. Many thanks that you are interested in the UNR 156 and ISO 24089. So I'm a technical sales consultant, so I create solutions based on our platform services like firmware update over the air or vehicle data, collecting vehicle data or OTA function call. Together with the customers and create a solution what fits to their needs and also to their environment. Beside this, I'm also part of the ISO 24089 standardization committee, so I supported in writing this standard. And I'm also part of different groups that are discussing the UNR 156. Here, the suppliers, but also the OEMs are participating these groups, and here we try to find a good interpretation of this regulation. Yeah, and with this, I would hand over to Thomas.
Yes, thank you, Sven. So yeah, my name is Thomas Stimm. I'm with ITAS since 2011. From background, I'm a security engineer. I'm working in the security domain already for roughly 2 decades, and my focus was always the automotive sector. Nowadays, I'm leading our consulting team, our local consulting team, but I'm also contributing to projects, international projects in many different roles and several topics related to automotive security. Yeah, myself will guide you through the first part of today's presentation. We will start with a rough overview, with a short overview of the UN regulation as a recap to pick everyone up. Then we will continue with the introduction into the ISO. As the next step, we will show you the dependencies, the relationship between the regulation and the standards, and at the end we will indicate ways towards a certified management system. Maybe you already joined one of my former seminars, webinars. I like to start with this quote quite often, so maybe it's already known to you. Mary Barra said, as a CEO from GM, that she believes that the automotive industry will change more in the next years than it has done in the last 50 years. And what she probably had in mind here is the trends in the automotive industry. So today's several hundred million connected cars are already on the road. I just checked for preparing of this webinar for some actual numbers, but there are different sources and nothing really completely let's say, confident. But what I find out is, for example, in the last year in the US market, over 90% of the vehicles are already connected vehicles. So this actually proves the trend of the connectivity. But why is connectivity now the pushing factor? So on one side, the manufacturers and OEMs see clear business opportunity, new selling points, but on the other side, the customer are also accepting those connectivities and new features coming with those possibilities and technical updates and features. Next, what's something we observe on the market is the tech companies that are originally not from the automotive market are also pushing into the market due to all those software and software connectivity behind this, as they have their sources and their roots, their background basically from software departments. They're also pushing towards the automotive industry to just enter new markets. So all in all, the amount of software, but also the complexity of software in vehicles is rising. And there are many millions line of codes in the vehicles. Everything is connected, communicating with each other. So this brings actually also new surface for attackers, new attack surfaces, so that software updates have to be also in the scope of security regulations to actually provide a process for this. But before I start with the regulation itself, I just want to show you also a little bit about the ecosystem. It's let's say an abstract overview just to show you that it's not only the connectivity inside of the vehicle, so let's say some Bluetooth connectivity, GSM connectivity, but also wired connectivity inside of the vehicle. There's also the connectivity to the backends, also vehicle to vehicle, also vehicle to infrastructure. So the vehicles are communicating, for example, with lights or stuff like this. But from software development perspective, we have like the OEM somehow in the center point, but there are different several interfaces. So there are interfaces with the suppliers that are providing the hardware, but also the software. There are interfaces with the tools they are interacting and using. There is interfaces with the actual OTA provider. It doesn't matter who is hosting this. This is the OEM himself or external provider. There is an interface. Everything has to be somehow arranged from development of the software up to the rollout of the software. And yeah, last but not least, there is not only the over-the-air update scenario and use case, but we still have the testers in the service. So yeah, as mentioned, beside all this connectivity inside of the vehicle, we have everything in the background, and this is just the abstraction of this. So to tackle all those new security issues and challenges that come up with the trend, there are two new UN regulations. Today we are focusing on the 156, but beside this, there is also, let's say, the brother or sister, the 155 regulation. And those two regulations actually provide a framework for the cybersecurity and software updates and for, let's say, disciplines. The first one is managing of vehicle cybersecurity. Then we have securing the vehicle by design. There is a discipline regarding detecting and responding to security incidents, and today's focus, providing safe and secure software updates. So the first three are actually covered a little bit more by the 155. The later one is the focus of the 156. So what is the 156 about? The purpose of the regulation is to uniform the provisioning of concerning the approval of vehicle with regard to software update and software update management system. So the regulation actually, or the type approval principally means that the manufacturers will need to demonstrate prior to putting vehicles on the market that they fulfill this regulation. So it actually means that it's required to get the type approval to be permitted by approved authorities to be permitted to bring the vehicle on the market. Scope-wise, the regulation has the software update management system on its own, where we will take a closer look in the next slides, but also like the software update delivery mechanism and the software identification are in scope of this regulation. Just as a short recap for the regulation, we will just introduce the sums slightly, while the other one are a little bit, let's say, more obvious what could be behind those topics. So yeah, what is SUMS? What is the software update management system? Here's the definition, the original definition of the regulation, and it says that the software update management system is a systematic approach defining the organizational processes and procedures to comply with the requirements for the delivery of software updates according to this regulation. And this means basically that SUMS is providing a framework for the automotive sector to put necessary processes into place. And to highlight here some of those processes that are addressed by this regulation, I just want to show you this slide and go through step by step. So first of all, there are processes required for the traceability and consistency of type-approved systems. So this means that it's required to record the hardware and software version relevant to the vehicle type, but also verifying that the software on a component is what it should be. Next, we have the processes regarding unique software identification. Some of you who already, let's say, come across this topic maybe in the past, come also across this term RX ISWIN. So this is what is actually referring by this, and this is unique software identification for software updates, but also for the initial softwares. What's next required is processes for the identification of type approval relevant changes. And this is basically the core of SUMS. So one have to assess if software updates are type approval relevant or not. Next we have process requirements regarding the independencies and compatibility of software. So one side is that, as mentioned before, vehicles are quite connected. There are several ECUs inside of the vehicles. Everyone the ECUs are communicating with each other, but there are also software dependencies inside of the ECUs. As for one ECU, often several suppliers are providing parts of the ECU and so on and so forth. So the compatibility have to be checked here on one side and the dependencies, but it's not also the compatibility of the software with itself, but also the compatibility with the vehicle, as each vehicle has somehow a different state and setup. Driving through the world, you can imagine that parts are replaced here and there. So each vehicle is somehow an individual setup, and it have to be checked if the update is also compatible with the specific vehicles. Yeah, on the right side, this is actually my main domain here. Is there are processes required for the security, and this means the example that the integrity and authenticity of the update should be ensured. Next, there are processes for safety to ensure that safe driving is not affected. Next topic is also managing of failed and interrupted updates. As you can imagine, not every update just finish well. You know it probably from your personal computer, from smartphones, and at the end, vehicle is also just a device. It's a big device, a quite complex device. But still, updates can fail, and there are processes required to actually handle those. Last but not least, there are some special action required, processes required for special action before, during, and after the software updates. On one side, for example, for the over-the-air update, it must be ensured that sufficient power to finalize the update successfully is there, but also there are requirements, for example, to inform the user about the updates, to maybe delay the update, or to give the road user at the end the opportunity to postpone something. Just to make some two use cases here. Yeah, last but not least, all of those processes have to be documented, and the information have to be shared with approved authorities. So there are a lot of processes requested by the regulation, but why one should implement those processes? Here I want to show you the overview of the World Forum for Harmonization of Vehicles, and this is basically a regulation. And this World Forum passes international agreements, the so-called UN regulations. And the UN regulation 156 is the regulation regarding software updates, but there are also 155 other regulations before this, and also some newer ones after this regulation that has been released. And if manufacturers and OEM are going to release a vehicle in one of those market countries, they are affected by the regulations, they have to fulfill this. So you just must be compliant for the type approval. Next, I want to show you the roadmap, but before we come to the roadmap, I wanted to distinguish two terms that those are often mixed up or people are confused. What is the difference? So on the one side, we have the type approval, and the type approval is typically performed by the OEMs for a whole series, for model lines and so on. And usually this is done in two steps. On the first, the OEMs actually perform the type approval for vehicle systems like braking, steering, emission system. And each system where the type approval is required here actually is referring to one UN regulation. At the end, or next on this, the OEM perform a whole vehicle type approval that are usually based on the system, but not only that, it could involve also some parts beyond this. On the other side, we have the registration. This can be done by the OEMs, but could also be done by an importer who is going to bring the vehicle to the market. And the registration at the end is for vehicle specific, for individual vehicles, depending on the production date and on the setup. It's actually registers vehicle based on the granted type approval. So yeah, having this in mind, I just want to indicate you, let's say, the hard lines of the regulation. Mid of next year, the OEMs have to fulfill the regulation R156 to get new type approvals or new vehicle type approvals. by mid of 2026, the regulation have to be fulfilled already for the registration of new vehicles. And there is even a further deadline by mid of 2029, and this is aimed for the so-called new completed vehicles. And what is meant here is actually multi-stage vehicles, for example, motorhomes or buses. Yeah, and this regulation is translated into national laws. This is here the deadline for the European timeline. There are some, minor changes here and there for other nations, as at the end, the nations are translating their laws. Yeah, so so far so good for the regulation. Now I want to give over to Sven to introduce the ISO 24089 to us.
Yeah, I will give you an overview about ISO 24089. First, we would look on the members, of the standardization group, and here you see that these are different to the UNR 156 members. So we start in Asia. Japan has at the moment the chairmanship here. So they lead us through the standardization. They do all the formal processes and so on. But then also from Asia, we have Korea and China in our group. Then we have a lot of countries here in Europe, like we, Germany, but then also France, Sweden, Italy, and so on, that are supporting here the ISO 24089. And in the US, then we have, in North America, we have then also the US and Canada, that are, working with us on the ISO standardization. I'm personally, I'm in the German delegation, the so-called DINAK, and here I'm also the second chairman of this group. What is the purpose of the standard? The standard had the headline software update engineering for road vehicles. And what means software update engineering? That's the application of a systematic and managed approach to the process of planning, development, and deployment of software update package. That's the definition, what we how we have defined the software update engineering. And at the end, it's to support the fulfillment of the UNR 156 in Europe, but then also other regulations from other countries. So, for example, the NHTSA in the US or the CNCA in China. The scope of the ISO is, as I said, software update engineering, but here on organizational and project level. And in this detail, what is mean the organizational and the project level, we will see now on the following slide. The ISO norm addresses the following main topics. It starts with the project management in general. Then, we have the software development for infrastructure and the vehicle components for software updates. Software delivery process of the software update content for the target ECU. That's then the third main topic what we have here. The update operations, like receiving of software updates, installation of software updates, and activation of software updates, is addressing the vehicle or the vehicle system, like here the ECUs within the vehicle. Then we have the vehicle configuration information, for example, the hardware version or a software version or the hardware ID and software ID from the ECUs within the vehicle. The software delivery documents are like release notes, for example, or like the software content, including the meta information. So here we are not only addressing the binaries of a software update, for example, we are also including the meta information here. And then we have the safety and the security requirements related to software updates. And last but not least, there is also the reference and the request for compliance to other norms like the ISO 26262 for functional safety or the ISO 21434 for cybersecurity. When we have a look on the right side, we see the different chapters in the ISO. Yeah, so here we have a little bit a different organization of the different chapters. So here we follow more a logical view compared to the content itself. Yeah, so some of the topics in the content are coming in different chapters. For example, when we have the safety and the security topic, yeah, that's is addressed in the infrastructure in chapter 6, but then also in the vehicle systems in chapter 7. But yeah, let's start from the beginning. Chapter 4 is addressing organizational processes like continuous improvement and document sharing. Then we are going with chapter 5 in the update project processes. And here topics like tailoring and interoperability are addressed. Chapter 6 now, we have the infrastructure to perform software updates. That's usually backend components, cloud components, what supports here doing software updates. In chapter 7, we are going now to the vehicle and the vehicle systems. And here the main focus is on the execution of software updates. Here we are addressing on one side the so-called FOTA master that performs a software update, but then there are also requirements in what are related to the target ECUs itself. Chapter 8 is about assembly of software update packages. So here we collect the content and the meta information and pack them together in one software update package. And in chapter 9, or chapter 9 itself, describes the preparation and the execution of software update campaigns. Yeah, that's an overview about the content here, what is addressed in the ISO. And when we go to the next slide, then we see the timeline. Yeah, so the request for proposal, this new work item, was provided at the beginning of 2019. Then the working group itself, it started in August 2019. And then there were a lot of discussions from 2020 to 2022. And there we also discussed a lot of drafts there, yeah, starting with the second working draft, third working draft, and so on until end of 2020 with the final draft of the international standard. And after getting then here the approval from all the contributing parties, all the countries that are involved there, we could release at the beginning of this year, February 2023, the international standard. At the moment, we are working on amendments, yeah, and also technical reports. So one amendment, what is at the moment in preparation, is to improve some definitions and also to improve some wordings in the standard itself. Yeah, so there are no main changes from the ISO norm itself at the moment here planned, but additional documents like a technical reports, they are at the moment in preparation and also in discussion. Two examples are the Korean colleagues. They are writing at the moment a technical report out of an example of a FOTA update project. Yeah, so it gives some explanations how they worked, how they run this project, but then also what experience they had, also with some best practices. Another topic, what is at the moment in discussion, is the configuration management. We are thinking about that a lot of topics regarding configuration management is managed in the different chapters of the ISO norm, but now we want to aggregate them somehow and give also some guidance how to identify the right configuration or configuration description of the vehicle, but then also of the update packages, and then also provide this as a technical report. Before I go or show a further concrete detail what was released so far, I just wanted to give here a short overview about the different possible documents. What are possible besides the international standard itself. The first document is a technical specification. It addresses a work still under technical development. The aim is that it will be eventually be transformed at the end and published as an international standard. The second one is a technical report. It may include a description, for example, of an informative report or of an example for state of the art. That's what the Korean are preparing at the moment. That's exactly such a technical report. And the last specification is a publicity available specification. It is published to respond to an urgent market need. It's representing the consensus of experts within a working group. And also here, the specification can be transformed into an international standard. And this maximum life of such a specification is 6 years. So that's only an intermediate step to react very fast of current needs in the market. One example or a further example for a technical specification is this request here. That's requesting a standard for human-machine interfaces for software update over the air. And this new work item was requested for voting in July this year, and it was also agreed here. So here also a new working group is working here on this specification for HMI, for user interfaces for over-the-air updates. That was a rough overview about the ISO norm, the ISO standard, and now we would to look a little bit more in the details and also have a look on the relationship between the UNR 156 and the ISO 24089. The UNR 156 addresses mainly the OEMs. So that's the border what we have, and for sure the OEMs cannot fulfill it by themselves. So there will be also will also forward some of the requirements to the suppliers like we or Bosch are. But the certification is a precondition to get a type approval for vehicle, like Thomas already said at the beginning. And also the certification needs to be renewed each 3 years. And that's why it's important to work on this. And as we know, most of the OEMs are already prepared to this and have also their first certification done. The ISO 24089 is more in detail. So it consists more detailed requirements. As we saw in the introduction, there is also it's a little bit splitted to the different stakeholders. So we have the infrastructure, we have the onboard components, and so on. And at the end, with this detailed requirement, we want to support here the OEMs but also the suppliers, in fulfilling the UNR 156. That's the main target of this standard. Around this standard, there are a lot of documents already released. The first one is the proposal for the interpretation document. It provides more details and explanation to each chapter, but then also to each requirement. This proposal is not released for now. So there are still some topics in discussion what could be also added to this interpretation document. Later on, I will also give here an example. The next one, what is available is the requirements catalog from the KBA. This requirements catalog should support the participants for audit of the CSMS, the security management system, and the SUMS. And here especially the OEMs should be supported here, but then also the technical services, when they do their audits according to the UNR 156. Here we find also more detailed requirements to support here these audits. The next, then we have the references to the ISO 24089. Here we also created such reference document, between the UNR requirements and the ISO requirements during our working phase. The intention of this was that we don't miss any requirements between both, so that we have in the ISO then also all requirements covered what are addressed in the UNR 156. But now this topic with the references was also addressed again by the SAE, and here it's also in discussion that this will be at the end put into the interpretation document. So they started with the first proposal, but now at the moment a small working group of specialists of the OICA and CLEPA Cluster 4 and the members of the ISO 24089 committee is working on these references. So I'm also part of this, and now we are going through and look on one side what is written in the UNR 156 and what are the related ISO requirements here, and we want to put this here in such a table what you see here on the right side. That's in work at the moment, and at the end, as I said, it will be most probably put in the interpretation document. Also to give here some more guidance and support for the audit. What is also maybe interesting for you is the way towards a certified management system. So we have heard now a lot of the requirements and how to fulfill the requirements, and then but at the end you need to do your certification. And we have here also created an approach to support in getting such a certification. Our approach starts with the gap analysis, with the so-called proof. Then we have the SUMS implementation. This consists of a process consulting and solution consulting. These are these two main phases, what we see here. The process consulting supports the process implementation, also with technical support to ensure that it will fit later on to the solution. The solution consulting itself, it addresses the requirements and the design of technical solution. including a security concept, to fulfill the UNR 156. And at the end, then we have the solution itself. Here there are some solution providers that provide here a solution, but you can also do this by yourself. So implementing your SUM system. And here, as an example, we have took the FOTA solution, what is also supporting the SUM's implementation at the end. And Thomas, can you tell us now a little bit more about the proof, so that we start here on the left side and give some more insights about this process, what we have developed?
Yeah, sure, Sven. Thanks for asking. Yeah, so the proof is actually a framework, and it provides an 8-step implementation roadmap. And it can be considered as the first iteration of the PDCA cycle, so of the plan, do, check, act cycle. In the first phase, we start with the scoping, where we are discussing what should be analyzed, with regulation standards and guidance should be analyzed, which department should be considered, which processes and other stakeholders inside of the companies are already there that we should interact with. This is actually the preparation for the stocking and planning phase, where we are performing a fit gap analysis. So we are checking which processes are already in place, what can we take over, for example, from the quality department, from IT department, or what's already there in the software development, and so on and so forth. We are doing this by moderating interviews, but also by reviewing existing documents, and are in discussion with the responsible departments. I will just catch the next part and not go through all of those 8 steps. So at the end, we are able to support the rollout in all domains regarding the processes, the toolings, and also for the competence. We are providing coaching, we are shaping the awareness, and so on, to finally come to the commissioning phase, where we guide and monitor pilot products, where we really support our customers to follow their own processes, where they maybe already had in place, or where they have reshaped, or maybe introduced completely from scratch. What else I want to say to this approach is that we are supporting also just in some specific points of this, so no one have to require all 8 steps from us. Maybe they just require some support at the beginning, or our customers require the support for the commissioning and do the remaining stuff by themselves. So we are really flexible here to support the customers. At the end, the ETAS approach guides from readiness check up to the commissioning and operation. And this is not only with regard to the UN Regulation 156 and the ISO 24089 regarding software update, but as well for the related security standards and regulations, so the 156 and the 21434, and beyond this. So here's a mapping what we're already able to do, what we have and implemented in our framework, and some forecasts in the backlog what we can do in future. The nice part here is that our framework is able to support the analysis simultaneously. So we are not going for each single mapping here for the same stakeholders in the same interviews. We are able to do this in an efficient way, just in, let's say, one iteration. But beyond this, the ETAS is an experienced stakeholder in automotive enterprise security. So our solution portfolio provides also other security products, services, and management service for the entire DevOps lifecycle. So we are not just an expert for the audits and assessment, and you can see in the top right here, but we are also able to do threat and risk analysis. We are supporting our customers in doing security concept, in guiding the projects and product developments through the completely life cycle, supporting them with testing. We are even able to do our own security tests, and we have different products for the embedded part, but also for the enterprise part. So whenever you come across security and you need a helping hand, feel free to search our website and get in touch with us or myself directly. But now back to our original topic, the software update and software update management system. So having the processes set up, Sven, how can we implement this SAMS from a technical point of view?
Okay, thanks, Thomas. Yeah, here we see an overview about the different parts and stakeholders of a SUM system. Yeah. To build up such a software update management system, we cooperate with test systems. Yeah. Core here is the type master of test systems. That's a component that supports OEMs in doing the homologation, yeah, in doing type approvals. Yeah. So it collects documents, it organizes documents, and at the end, it provides the documents then for the type approval to the type approval authorities, but then also to the technical services. Yeah. Besides this, beside the type master, one main component is our over-the-air update system. Yeah, the over-the-air OTA update system from ETAS. We are working here together in a public funded project, the so-called SoftDCAR, where we invest how they can interact, these different systems. And at the end, the target is that we have defined interfaces to exchange necessary information. And here between all the stakeholders, so we provide the information to the SUM system, from our OTA update service, for example, the result of a campaign, but then also the inventory of the vehicle will be provided, and the SUM system then again will forward all this information to the approval authorities. Also between or beside all these regular things, there are then also the reports, the yearly reports, what are requested by the authorities. Things like this will be handled in this SUM system. The target of this public funded project is to define here interfaces, defined interfaces, so that we have here a kind of standard, in interacting here to support in a software update management system. How can we, with our OTA update solution, support UNR 156? As I said in the previous slide, it starts with the inventory. So the current vehicle configuration is important and is requested from the regulation. And with our solution, we can collect the current software version, the current hardware version, or other things what are provided from the vehicle, and write this in our so-called inventory and provide this information then to the SUM system at the end. The next level then is the campaign itself. So here are a lot of features that are supporting the UNR 156. The first is that the targets needs to be identified, and in our solution we can define the targets by using again the inventory, so the current configuration, but then also other properties like, for example, the model of a vehicle or other parameters what are defined before. Another important thing, also like Thomas told in the introduction, is the precondition. So the vehicle needs to be in a safe state, for example, in a parking position, or it needs to have enough power in the battery so that the full update process can be finished, and then afterwards the vehicle can be also again started. Then we have the interdependencies that needs to be checked and managed from the system. And we need to handle failed update or interrupted updates. Here, for example, the download can be continued. Yeah, so if you have an interruption in the download, we can continue and not start from the beginning. But then also features like rollback or fail-safe are supporting here this handling of failed updates. Yeah, another important topic, what we also had at the beginning is the documentation. So beside the inventory, it's also also important to document the campaigns. So when a campaign was assigned to a vehicle, this information is important, but then also the result of a campaign. So was it successful? Were there some retries, or was it failed here in this case? Yeah. Within a campaign, we have also the user notification, what is requested by the regulation. You need to inform the user for an upcoming update. Yeah? So sometimes you also inform them, okay, which of the features are not available during the update. And yeah, at the end, you can also ask him then for approval, also to support the safe state of the vehicle here. The RxS Win is also an important topic. So the RxS Win is the relationship from the type approval of a system, to the software versions then itself, the software components what are in the vehicle. And this RxS Win, if it is stored in the vehicle, we can update this RxS Win version in the vehicle, and we can also collect this RxS Win information in our inventory. And last but not least, there are a lot of security and safety mechanisms addressed in the UNR 156, what we also support. So, for example, in the security, we protect the packages against manipulation here by using a signature, or we can also encrypt the update packages here. And for safety, we have also some components that supports here for FOTAP functions that could come up or go up to ASIL D here. Yeah, that was a rough overview. What features are requested from the UNR 156 to a OTA update system. Yeah, most of the things are not only necessary for an over-the-air update system. Most of them are also required for doing updates, for example, in the workshop. And with this slide, we are also at the end of our presentation, and would be now happy to answer your questions.